And then we are all set. Actually worked out pretty well. Like I mentioned, we had quite a few people kind of straggle in here while we were doing that. So without further ado, let's get after it. We can have more people who are joining. I'll make sure to let them in. And then Addie, thanks for sending that message as well. So as you guys all know, we are connecting today. It's our first webinar of 2023, and we're going to be talking about the California Building Code 2022, and then the changes that specifically apply to the residential structural engineers here. And like I mentioned as well, quite a few of you already found it, but feel free to say hello in the chat and keep that chat going. So most people in here are either users of ClearCalcs or you've used it in the past, trialed it in the past. But as you guys know, clearcalcs.com, if I could talk, cloud-based platform, more accurate, eliminating wasted time, and then of course available everywhere, whether you're at a coffee shop, on site, at the office, at home, or just in the car and need to pull it up on your tablet. A new slide we're adding in here kind of this year, just because we are adding quite a bit, even each week. We're going to highlight a few of the recent updates that we've done in ClearCalcs. Of course, these applying specifically to today's webinar. We do have CBC 2022 implemented into ClearCalcs. We've added, as Laurent is going to talk about later, seismic loads. And then we're also very excited to say we have removed shear walls from the beta tag. So that way you guys can use that shear wall calculator full without any restrictions on that printout. I know I've chatted with a lot of you guys before, but myself, I'm our Director of Customer Success, Connor. If you guys ever have any questions, ever need to connect for a training session, anything like that, reach out to me. And then we also have Laurent, who I'm very excited to say, and I'm sure he is as well. We're able to add that professional engineer tag next to his name since the last time we did one of these webinars. So congrats, Laurent. But he heads and leads our calculator work in the US and Canada. So again, I kind of use this slide to fill some time and filibuster a little there earlier. But if you guys haven't found it yet, use that chat button to send any questions, any comments. You could either send them directly to myself, or Addie's joining here as well to assist a bit, or just send it to everybody, and then we'll make sure to touch on all those questions in the last half of today's webinar. And then I'll pass it over to you, Laurent.
Okay, thank you, Connor. Hi, everybody. Thank you for joining us today. I think pretty exciting one today to start the new year with a new building code. I'm going to guess most of you are coming in from California. Maybe you woke up on January 1st, a little hungover from the party and realized there's a new building code in town. Like, oh no. So hopefully the hangover's over, but we'll be here to help with the California building code. So I'll start with a bit of a warning here. We'll be talking a lot about the building code. This is not comprehensive. I am not promising you whatsoever that I'm covering every single change in the California building code. I think of this as a bit of a curated playlist of things that came up during the code updates. There's a chat box right there. If you see something that I missed or something like that, or that you think is interesting, just throw it in there. I'm sure everybody else will be more than happy to just kind of learn from you. So please feel free to share. We're all here to learn together, basically. Our focus, with that said, will be mostly on kind of single family residential and small scale commercial things. Big one here, obviously, the California Building Code's got some special provisions for things like hospitals and other institutional buildings. So we're not going to be looking at those today. But things that we will be looking at is basically, what is the CBC? What are kind of some general changes that came up with the latest edition? And then specifically things that came up with wood shear walls and with concrete as well. Especially with concrete, you're going to want to stay tuned for this one. There's some pretty big changes in there that are probably going to affect some of your designs. So what is the CBC? It is the Canadian Broadcasting Corporation. It was founded in 1936. It's our national broadcaster here in Canada. But but you might not care about that. So we're going to focus on the California Building Code, which is the other famous CBC. It is part of California's Title 24 regulation, and it is basically the law of the land in California for any kind of building or building structure, with a couple exceptions here and there, but generally that's what you'll be dealing with. One important part here, it is the law of the land, but your local jurisdiction can also have some local amendments that are more conservative than the California Building Code. And they do this typically through having an ordinance passed. And so the department or building science, I forgot what the S stands for, but the Commission for the Building Codes of California keeps a list of these. And so you'll be able, whenever you're perhaps working in a new jurisdiction or you want to double check for your own, you're able to track where that happens. So we'll do a little example here. We're going to look at the town of Pleasanton, California. And so I'm just going to go to the Building Commission website. So if I come here, you'll see this is the Building Standards Commission. There you go. And so they've got their 2022 ordinances. And so there's a big warning here. These are still coming in. Obviously, the standard just got adopted. So it's quite possible that more ordinances will come in. But for now, there's a list here. And so we said Pleasanton, California. So if I scroll to P, I can see every single jurisdiction in California. If there's nothing and it's just white, that just means that they haven't adopted any kind of significant amendments. If I look and I scroll, I'll see Pleasanton, and I just see a 2241. That means it's ordinance number 2241, and this is what we'll be able to go see now. So if I scroll up, there's also an email CBSC. So some of these ordinances, I've went around, looked a little bit. Some of them are easier to find than others. So if you're having trouble finding them, you'll be able to just send them an email and the Building Standards Commission will reply to you with information. Just speaking from experience, they're really good. They answer really fast. So it's a great service that they're offering. So if I look now, I can go pull up Ordinance 2241. So this is for the city of Pleasanton. And I can see the most significant one in this case is they adopt the California Building Code, but they amend section 1905.1.7. And so I apologize. I've got the little bar at the top. That's okay. Here we go. If I go in the California Building Code 1905.1.7, I can see that this has to do with plain concrete. And if I just quickly look, I won't read through all of this with you guys, but I can see that for one, the first paragraph here is missing. And that basically says, I think, if I'm reading correctly, that basement walls in the city of Pleasanton basically need to be reinforced. And then if I look, there's these two exceptions, and these are removed from their modified section. So that means these exceptions wouldn't apply in the city of Pleasanton. So this is obviously just for one jurisdiction, but just to kind of show you, these are the kind of changes that you might see for your local jurisdiction. So it's always a good idea if you are designing in a new place to just double check and make sure that there's no surprises. Okay, back to the presentation now. We're going to be looking at the California Building Code. So some questions we've been asked before is, what is the California Building Code anyways? So it is based on the International Building Code. Actually, in most cases, it's almost the same every single time. Now, the International Building Code is released every 3 years. So there's the 2015 version, 2018, 2021 is the latest one. Next one will probably be 2024. And the CBC, it's typically released 1 year after the IBC. So that will include basically all the amendments that are specific to California. And then once that's released, that's typically around like mid-year. So I think this year it came out around, I want to say June 2022. And it comes into effect the January 1st of the year after that. So like we said earlier, January 1st of this year, 2023, CBC 2022 came into force. Now, there's some changes like that. One thing I like to bring up is there is a 45-day public review period. So you have the opportunity as a designer, as a member of your community, to make comments on the upcoming CBC. If you think some amendments are justified, if you think some are missing or something like that, there is that 45-day public review period. So next version of the CBC, stay tuned for that, because that might be an interesting way either to contribute or to make sure that things make sense for you. So looking at some general changes here, and a lot of these changes actually come from the update to the International Building Code, which the CBC is based on, but they obviously apply in California as well. So a big one you'll see, if you don't own a copy of ASCE 7, you probably want to buy one, because most load calculation and all the load combinations basically live in ASCE 7 now. It used to be, I'm sure you remember in previous editions, you kind of had the ASCE 7 load combination on one side and the IBC load combinations on the other. It was kind of annoying. It's kind of redundant, some slight discrepancies. It was a bit annoying. So they basically just said ASCE 7 takes care of that. So you'll definitely want to have a copy of this. Another one, this is an interesting one, wind zone location. So when you're dealing with components and cladding, you've got your different wind zones. I got a little picture here on the bottom of different areas. It used to be on drawings, the only thing that was required is to show zone 3, this is the pressure in PSF, zone 1, this is the pressure in PSF. Now you actually have to show the locations of each zone and their dimensions. And the idea here is that these zones can get a little tricky, especially if you don't have kind of a nice rectangular building. So to make sure everybody's on the same page, especially if you're going to have, say, an external or a separate designer design the cladding itself, to make sure everybody's using the same pressures, you're going to have to show these locations and dimensions in your drawings. And lastly, we've got some requirements as well for special inspections. So structural observations. So when you need a professional engineer to go on site and actually make sure the structure is built as designed, they've actually added some requirements specific to what you actually have to do during a structural observation. So that wasn't there before. It's kind of nice. And they've also added more criteria. So now if you're anything in risk category 3 or 4, you're going to need to do a structural observation. Or if you're in seismic design category E and your building's got more than 2 stories above ground, you're also going to have to go and do your structural observations. And then they've also added some requirements for mass timber and specifically steel storage racks as well. So if you're designing with either of those things, just make sure to keep an eye out. There's a couple other things as well. I did say this wasn't completely exhaustive, so worth taking a quick look there. Now, seismic loads. The California Building Code 2022, they're still using ASCE 716, but since the last version came out, there's been 2 more amendments on the standard. And basically what these do, the biggest thing is site-specific analyses. Actually, if you want to post in the chat, I'm really curious if you typically do these site-specific analyses. Our understanding here is that they're quite a bit of trouble and they can be quite expensive to do as well. And so one of the big things was site class D. So when your soil was for site class D, you could end up having to do site-specific analyses. Now, what these amendments do is they basically clarify when you can get away without one. And so for site class D, they basically say if SS is greater than 0.2, which is probably most of California, you basically increase your 1 second acceleration, your design acceleration, by 50%. So typically, again, for residential or short height buildings, this probably won't have too much of an impact on loads. And then for site class E, so if we've got SS greater than 0.2 or S1 greater than 1, so again, big earthquakes, probably quite common in California, they're basically just always use the short period acceleration, which is kind of the conservative estimate. Again, if you're typically dealing with like a residential structure or a small scale commercial, that's probably not going to have too much of an impact. But the nice thing is now it's clarified. So you know when you don't need a site class a site-specific analysis. There's a couple other changes. That's more if you're doing kind of like the fancy modal analysis or something like that. I'll let you go through that if that's the kind of thing that you're doing. And that little hint here, we've just released our seismic load calculator. And so you'll be able to find kind of your base shear based on your building weight and based on your ground accelerations. And we do also incorporate these 2 exceptions here with the site classes for the site-specific analyses. Next up is foundation. So an interesting one is exits with out-facing doors need to be frost protected. This is a new one, and basically it's to make sure there's no frost heaving in front of the door that blocks the door when you push it open in an emergency or something. And I found this picture on the internet. I thought it was funny. That's exactly what they're trying to prevent with that clause. Obviously, most of California, you're probably not dealing with too much frost, but if you're up in the mountains, that's something that does come up. So basically, you're going to want, the typical scenario here is you're going to want to extend kind of the insulation for your foundation a little bit under your door opening radius. As well, most deep foundations, so piles or helical piles or something like that, have had some updates. Notable ones here, precast piles, now they're very explicit. You're designing them for ACI 318. If you're in high seismic zones, aka most of California, you also have some stricter requirements for piles. In particular, they're referring to AISC 341 now, which is the seismic design for steel for your piles as well. So something to look at as well if you're designing with that. Curious to hear actually in the chat if you design these deep foundations often. That's not something we have in ClearCalcs right now, but it's definitely something we've been looking at. Next up, we're going to be talking about shear walls now. And so that is the special design provisions for wind and seismic. A bit of a mouthful for that abbreviation, but that is the code for wood shear walls and diaphragms in the US. So previous version was in 2015, and now we've got the 2021 version. Big things here, there have been some slight reductions in strength. So for wood panels, if you're designing an LRFD, you can typically expect to have 11% reduction in strength. And then if you're designing an ASD, if you're using gypsum board or plaster as your panel to resist shear, you can have up to 30% reduction in strength. And so that applies, basically they've unified the way safety factors are handled, the way strengths are provided. And so these two they're the victims of that unification. Though I think in California, it's probably quite rare you'll be using that gypsum board for your shear walls. Feel free to share if this is going to affect you or not. We'd love to hear that. Other things, weak stories, if you're in high seismic categories, they're much tighter now on what's allowed in terms of weak stories, even tighter than what's allowed in ASCE 7. So if you're typically used to dealing with the ASCE 7 provisions, you do want to take a look at the latest special design provisions, because they'll have some new rules for the weak stories. And lastly, CLT. So there's actually provisions for CLT shear walls and diaphragms now. That's cross-laminated timber. Curious to hear if you've ever designed with CLT as well. It's something that's new and exciting. Would love to hear if you've seen projects that use it. And now this is the big one, concrete. So we've updated now from ACI 318 2014 to 2019. This is probably where you're going to see the most changes in your day-to-day designs. Big items here. We're seeing a lot more higher strength reinforcement. And so up to 100 KSI is now allowed. It used to be 80 KSI, so now it's 100 KSI. Curious to hear if you guys ever use high strength reinforcement. In our experience at ClearCalcs, we've mostly seen 60 KSI being used, but times are changing. So we'd love to hear if you're seeing a change in your projects. And then the next one is the concrete shear capacity. This is what's going to hurt. And so basically the formula for concrete shear strength has changed. That's for the cases when you don't have any shear reinforcements. So if you are dealing with no stirrups or something like that, when you just have using the concrete strength. So in ACI 318.14, it was a nice simple equation. In ACI 318.19, this is a bit of a mouthful again, but this formula works out, especially for lightly reinforced beams or slabs or footings. This works out to be about half the shear strength as you get in 2014. So you can expect, where we would expect to see the biggest change is going to be in footings. And so we're just going to do a quick example in ClearCalcs here, just to kind of show what this actually means. So I'm going to switch now. Okay, so this is ACI 318.14. So I've got, this is a spread footing. I've got kind of a big column coming on top of it. This is just an example I came up quickly. And you can see it's 12 inches thick. Everything is passing. Life is good. just looking quickly, we can see it's basically carrying a 44,000 pound dead load, 80,000 pound live load. So now I'm going to go. So this is our ACI 318-14 calculator. We've just released now our ACI 318-19 calculator, which is the latest edition of ACI. And so same column. And if I scroll down, you'll see same loads, 44,000 pounds, 80,000 pounds. And same thickness, 12 inches. But as you can see, we're at 171% utilization on our shear. Let's just go back to the ACI 318-2014. We were at 100%. So we've gone from 100% to 171%. That stings. And so how do we typically deal with shear in footings? We increase the thickness. So if I go to, say, 16 inches, still failing, I'm going to need to go to 18 inches. So I've just added 6 inches of thickness to my footing to pass for the latest code. So that's the new law of the land. The formula has changed. So unfortunately, that does mean you're probably going to be using a lot more concrete in your footings. Wall footings will be even more affected as well. So keep an eye out for this. Unfortunately, it might mean you have some awkward conversations with clients now, but that's the law of the land. So we'll need to be designing with this in mind. So going back to the presentation now. There's also this lambda S factor, the shear size factor. And what that does is basically, just in case you felt that not enough shear strength was taken away from you, we're going to take away even more. And this size factor, luckily, it's actually not going to affect too much. We'll go into this. Anything that's over 10 inches deep and doesn't have stirrups or any kind of shear reinforcement is going to have its shear strength further reduced. So example here, if you've got a 24-inch thick slab, your shear capacity just went down by another quarter. So it went down by half, and now it's getting cut off by another quarter. Luckily, at least for footings, they're accepted from the size factor. So that won't affect your footings. But if you're dealing with kind of thick walls or slabs, this will affect your design. Now, for typical small scale residential or commercial, this is probably not going to be too big of an issue, but it's good to know next time you see the formula, at least to know it exists. Okay, so we're already at the end here. So quick conclusion here, CBC 2022, it's the law of the land. If you're designing anything in California, you better get familiar with the 2022 version. We have seen there's some local ordinances that might change CBC 2022, and it's only allowed to be more conservative. So that means you definitely want to take a look to make sure that you're not under designing for your local jurisdiction. So there's that. We've gone over some of the most significant changes. The biggest one, as we said, is going to be the shear strength with concrete. That's just drastically reduced, almost by half for footings. So you might expect to have some awkward conversations coming up there when your footings are much thicker than they've been for the last decades or so. So that's what we've gone over. And with that, we'd like to thank you. We ran a little bit short here. I guess I spoke a little too fast, but that's going to mean more time for questions if anybody wants to do that, or comments or anything. You will get a recording of this by email after. And we're going to do a quick survey at the end. Please, please, please fill it out. It's a big help for us in learning how we can make these better, more useful for you, or just new subjects, things like that. And we're going to do a big Q&A. We've got a bit of time, so I'm hoping we're able to answer most questions that come up here. But if you have more questions that come up later, you can always email us. Hopefully you've emailed us before and seen we try to reply really quickly and try to be good at this. I might have replied to some of you directly as well. So please send us a message. We'll be more than happy to help or take down your suggestions. So with that, let's jump into the questions period.
Yeah, thanks, Laurent. A few questions came through. Addie, that's actually a great question that you sent me. Laurent, can you quickly just show how to specify the new CBC in ClearCalcs, just so people can see that?
Yes, absolutely. Whoops, what did I just do now? Let me jump into ClearCalcs. Here we go. So you can go in your project defaults here on the left, and hey, there you go. You caught me. I'm actually running an IBC 2018. If I scroll down, you will see California Building Code 2022. You can just select that. And so this is what's going to show up on your exports, your PDF exports when you're done. And it basically makes sure that if there's any amendments from California, they're going to be applied to the right calculations.
Awesome. Then, no, yeah, that definitely answers it. Thanks, Laurent, and great catch there, Addy. Laurent, question really quick, just when people are seeing this, they're choosing CBC 2022. At the moment, it says that note about concrete. Wonder if you could just shed some light on that, just because I'm assuming that will be a question.
Absolutely, yes. So concrete not yet supported. We're actually right in the middle of finishing up our updates here. So you saw we've got our spread footings, we've got our concrete beams. We're basically going in order of what calculators are the most popular on our platform. So these are the two most popular. And so we've updated them. Coming up next will be wall footings, concrete columns, pier footings as well, and then our base plate calculator as well. So we're basically going to update all of them to be conformant to ACI 31819. Until then, just kind of as an abundance of caution, if you're using California Building Code 2022 or IBC 2021, which is also referring to the latest ACI, we're just going to tell you it's not supported just to make sure. But if you say selected the California Building Code 2022, you'll see it does work with ACI 31819 with our spread footing. If we look at our 31814, however, California Building Code needs the basically it doesn't pass with the California Building Code.
All right, thank you, Laurent. I'm looking through the chat here. So Mo asked a question here and asked, can we add more reinforcement for the shear rather than increasing the depth? I know that's a bit of engineering advice there, but I guess is that an option that's on the table for a designer?
Absolutely. And so we have heard of some people, even for spread footings, which typically don't get designed with shear reinforcement at all. We have seen some people kind of coming up with designs that do include some sort of stirrups or some shear reinforcement. But it's a great point that's brought up here. If we look, let's go in Clear Calcs and look at our shear formula. So one-way shear capacity, you'll see this rho W here. And this value, that's our reinforcement ratio for flexural reinforcement. And so you'll see if we increase our flexural reinforcement, it will increase our shear strength. So if I come here and let's just say right now I've got 9 bars, let's go with, I don't know, let's double it. Let's go to 18 bars and 18 bars. That does increase our shear strength just a little bit. Unfortunately, the reality is it's kind of the cube root of the reinforcement ratio. And so that basically means if you want to double your shear strength that way, you're going to need to put 8 times as much reinforcement in your footing. So realistically, I mean, it might work in some situations. Likely what you're going to want to do is probably just to increase your thickness and add more concrete.
Thanks, Laurent. That was a really good explanation there. Throwing me back to math class with the cube roots and all that fun stuff. And then Matt, thanks for your question here. So he mentioned in your presentation, there was a slide about amendments to the ASCE, if I could talk, 716. Just hoping for some clarity there. Did that mean that there were changes to 716? Or that CBC 2022 just now follows that completely instead of making its own rules and all that?
Yeah, thanks, Matt. And thanks for attending today. Good question. So the amendments, and you know what, just as you said in the question, I think it clicked in my mind. It's not actually an amendment. I think it's called a supplement. And so a bit of a typo here. My apologies. So the supplements are published by ASCE. They're not part of so the CBC 2022 says use ASCE 7 and those supplements, but it's actually published by the ASCE. I'll pull them up really quickly. Let me just look here.
And then Mo, just seeing your question here. Yes, so you, as you're pulling that up, Laurent, Mo, who had asked the question about the steel reinforcement, mentioned that we could probably increase the concrete strength since we were only using 2,500 PSI. Yes, if you know, and Laurent, correct me if I'm wrong, but if you know you're using higher strength concrete, you could definitely change that. In ClearCalcs, we just default to 2,500 and then just kept it there for example's sake.
Absolutely, absolutely. So you'll see if I bump up my concrete strength here to 5,000 PSI, my shear utilization goes down a lot. So we have 2,500 here by default. That's just what we've heard is kind of the typical concrete strength for footings. But if you're constantly switching your concrete strength to more than 2,500, absolutely, you should be changing that to get the most shear strength you can. Would be curious to hear actually what typical strength you guys are using. Feel free to post that in the chat. And so Matt, just coming back to your question. So this is the supplement 3. So it's published by the ASCE 7, and they basically, it reads it's kind of a little clunky to read, but they just strike out the parts that they want, and then they just enter the new clauses here. And so this is what we're referring to with the supplements. I hope that answers your question.
Yeah, great point there, Matt, on just bringing clarity to that.
Oh, and I see Sarah, that ResiWork typically uses 2,500 PSI to avoid special inspection. There we go. So thank you for sharing that, Sarah. That's great.
Yeah, thanks, Sarah. That's all the questions as of now. I'll definitely hang around for a little bit longer. If anybody has any other questions, anything that Laurent has chatted through so far. Another thing that wasn't brought up that very, very interested in everybody's kind of take on this. The engineering team, as everybody knows, we basically prioritize our work based on feature requests from users. And one thing that we've heard from just a couple people is the overstrength factor, seismic overstrength. So curious to hear in the chat if anybody uses that often, if it's something that's required on your permit submittals. I'm very curious there because the engineering team has been talking about potentially adding that into ClearCalcs.
Yeah, I would love to hear your thoughts on it. Send us an email too if you want. It's something that we're looking at, and we think it might be useful, especially if it's, say, multiplying your earthquake loads by the overstrength factor for specific components or something like that. The more we know about how you're typically dealing with this, the better it's going to be for everyone, and the more helpful we can make our software.
Yeah, thanks, Matt. So Matt mentioned he uses overstrength factor of 2 for anchorage equipment all the time. And then also, Matt, thanks for that comment. It looks like similar to Sarah, so he's using that 2,500 PSI for resi, and then he bumps up to 3,000 PSI for commercial.
Oh, thanks for sharing, Matt. That's great. And yes, so overstrength factor of 2 for anchorage equipment. So that's definitely something that we're looking into adding there, basically to help you skip that part.
All right. Well, we don't have any more other questions coming through. So figure Laurent, myself, and Addie will hang around for maybe another minute or two. If anybody who's in here, if you guys want to go grab a coffee, kind of jump on the project, get a 23 minutes back in your day, feel free to do so. We really appreciate everybody joining. Like last year, we're going to have at least one of these every month. Hopefully we can get to the point where it's a bit more, but hopefully you guys found this useful and Laurent's quick rundown of the new CBC 2022 helpful.
Yeah, and I guess we've got the time booked. So if you've got questions about ClearCalcs in general too, more than happy to kind of go through it with you while we've got the time. Or if you've got some tips you want to share with other people on here, go ahead and do that. Yeah.
All right. Analia, yes. So Analia asked, she came in a little late. Are the slides available? So yes, we'll send out this recording to everybody who registered so that you'll be able to watch it back. Check out the slides that Laurent ran through. And then of course, send us an email. Any questions, any friction points, anything like that you come across while watching it, definitely email help@clearcalcs.com, because like I've mentioned to many of you guys before, I get those. And then our on-duty structural engineer on support duty gets those as well.
All right.
All right. Well, we'll go ahead and call it then. If you guys do have any questions that I'm ending this a bit too early, again, email help@clearcalcs.com and we'll be sure to get back to you within a day.
Thank you everyone for joining and for your time and for participating. This was great.
All right. Bye, guys.